Okay, so today we're welcoming James, who is a master's student at the Iceland School of Energy. James was curious about new methods to investigate the location of magma. He decided that one effective way to answer this question, in the absence of conclusive evidence, might be to interview top experts with various backgrounds in order to probabilistically model the location of magma. Okay, so tell me a bit about those conceptual modeling sessions that you worked on.
Right, yeah. So we interviewed 6 university and geothermal industry experts during these sessions, ranging from volcanologists to geophysicists. We found that few people agreed on either the shape of bodies or their location. Some experts believing that the magma is contained in a large number of sheet-like dikes and sills. Some believe that there are larger, more blobby bodies, usually one large mafic chamber and smaller felsic chambers. Various combinations of sills, dikes, cone sheets and magma chambers were suggested.
Those models sound quite varied. Is there any data to support such a variety?
So one of the most extreme concepts had magma contained solely within a swarm of small cross-cutting dikes and sills. Taking a closer look at the data, defining the S-wave shadows, one signal did traverse the zone east-west, which is unlikely for a large molten body. So on the other extreme, the interpretation with the largest magma bodies is supported using contextual and heat flow evidence. The heat coming out of the Krafla system is considered extreme, producing voluminous basaltic magma, powering a long-lasting geothermal system, as well as melting the crust to perform rhyolitic melt. However, there is little seismic or deformation evidence that magma has moved under the caldera since the Krafla fires in the 70s and 80s, and no eruptions have occurred near IDDP-1 or K39 since Viti erupted in the 19th century. Therefore, some experts believe that magma intersected in the wells must belong to a large enough body that it has not yet crystallized. It is also considered unlikely coincidence that both wells intersected small magma bodies not only at similar depths, but also of similar composition. The basaltic source must also be large enough to generate the significant quantity of rhyolitic melt proposed.
Wow, that's quite compelling. Sounds like there's a variety of lines of evidence that were used to support these models. Is there anything else that might have been contentious?
Well, another point was the treatment of the microseismic events frequently recorded in the area. Some said that these are impossible within a molten body and should therefore constrain the bodies, while others argued that they may also be associated with the propagation of intrusive bodies. Several of these are located very close to the magma intersected in IDDP-1, and all of this highlights a subjective interpretation of geophysics data. The geothermal well data is the least controversial, as no one's going to argue whether magma is present when you're retrieving fresh volcanic glass chips from a borehole. However, even this data is biased, as the generally vertical drilling is likely to undersample vertical or steeply inclined features, meaning that wells are more likely to intersect sills than dikes, for example.
So James, let's just think about this a little bit. You've presented quite a bit of a grim point of view on the different data sets. How much do you believe these modeling sessions, and what value do you see in them?
I think none of them are going to be completely correct. Even talking to experts in the field, there's this huge range of different points of view. I think possibly the size of the magma bodies may be too small to model in a reasonable way. But the only way we can really find out more is to drill more wells and look at the data more closely. But it's a very difficult problem to answer.
Yeah, that's for sure. So let's hope that we get quite a few magma boreholes during the KMT project.
Here's hoping.